So, welcome everybody. It's 3 o'clock and we try to start on time. I'm Swiss and that's one of our things, that we don't wait for the people coming late. My name's Petr Beles. Please feel free to contact me on LinkedIn because we will have a lot of things to look at today and the 30 minutes will be very short for that. As well, if somebody wants to talk to me personally, I'm out there at the Datavault Builder booth, so don't hesitate to come over, ask your questions if we didn't have time to answer everything. So today we want to look a little bit on 3 challenges to building a CICD pipeline in data analytics. And yes, we will propose our solution, but for me it's as well important to draft the problem, because the problem might be more universal. You might find your own solutions, but that we understand why this topic is so complex. At least in my opinion. If somebody thinks that CICD is a very simple topic, please hands up. So you're either asleep. Does somebody think it's a complicated thing to achieve? At least a few more. Okay, good. So why are we doing this? The very simple thing is, and I'm always trying to draw very simple models in the beginning. We have a question, we need some analytical data, and we make a decision. And hopefully we have this data in a very good quality. And we want to minimize the time to market or time to insight. So how long does it take from getting a new requirement until delivering the answer to my question? That's a measurement that is, for me personally, important. I want to know how fast I can deliver whoever needs information, that he can take a decision. The problem is, on the way we have changing priorities. So the business questions are there, but somebody finds out it's end of the year closing, we need some other report, somebody needs to be changed, so we need to move out of everything what we were doing and move in something else. And this is one of the driver of continuous integration, continuous deployment for me, that we can decide at any point in time to deploy smaller bits of what we did, and that we can deliver something that we started in development later, earlier to production. And what is then good quality? Good quality has so many different aspects. It's about having the data at all, at the point in time when you need it, that it's updated regularly, for me that it's integrated, that it has a meaning, that there is a meta model, that we know what the data is telling us, but sometimes we have figures and we don't know how to evaluate what we received. And by trying to solve all of these issues at once, and maybe a little bit to my background, I started in data warehousing in finance and telecommunications back in the year 2000. We did already back then solve this kind of issues, but we did it with many different tools working together. We had modeling tools, we had ETL tools, we had some tools to create objects in the database, we did some manual coding, there was always an Excel sheet involved, and then some separate data profiling tool, lineage needed to be written, and trying to become agile with this heavy burden of many different tools just didn't work out. So that's for me one challenge, having many different tools that need to correspond, that you need to deploy at the same time and need to bring into your CICD pipeline. There's the second challenge. When I started in data warehousing, it was pretty simple, I think. We had 3 environments, maybe a little bit more, but we had development, test and production, and we had our 6-month releases, or maybe once a year or every 4 months. It was a really nice world. We compared just the environments, we bundled our release, and when we were ready and it was decided what goes into the release, we deployed it. And now people come along and say, yeah, and now do this, but just quicker. And this doesn't work, because if we have one integrated dev environment, we don't know how to separate the single changes from each other. So in fact, today it looks like everybody of us needs to have its own sandbox. And that's for me the basis for distributed development. The funny thing is, if you ask the Java people, they do it for years. And in fact, everything that I'm telling today is nothing that I have invented. I talk to a lot of Java people and we try to bring everything they are doing in agile development to the data warehousing world. So good. So we need sandboxes. We don't know yet how to do it. And what's the third thing that we need to solve? It is a very complex process, because I've been in meetings where we started gathering the requirements, and it was like, yes, we need to do agile development, we agree on that. We need to do some kind of automated regression testing, because if we do this regularity deployments, we want to sleep well, and we all had these cases when Friday afternoon everything goes wrong and we need to work the weekend. We just want to omit that. And we need to automate the deployment. So that was like a basic list of requirements. And then when you try to implement this kind of stuff, you figure out, okay, agile development means distributed development. And please, if you disagree, just throw me some looks. No, okay. We need code versioning, because we need to know what we did at which point in time, because in the worst case we need to roll back, and still the other stuff stays. A little bit later we figured out, but wait, if we do distributed development, how we bring the different parts of our development together. So we need branching, we need merging, and we need versioning of it. The good thing is, the people around the Git development invented all of this. They have documented it, there are books on it, it's a well-defined process how you do it. You just need to bring your development in a format which is compatible with Git. And this is one of my main points that I criticize with many products. They say they are able to work with Git. But if you look what they are checking into Git, it's not at all compatible. Most of the tools are deploying like their Delta deployments into Git. The next time you do the next Delta deployment, they deploy this to Git, but it's nothing that you can compare. You don't see the changes, you don't see the state. Git is built around states, about what you want to achieve. And then there is a second thing, the delta of what you need to roll out to a certain environment, because while we're not working like in the Java world where we can just build everything from scratch, we need to work with systems that have already data loaded, and we need to deploy the delta, okay, but we need to as well know what is the state that we want to achieve. And this should go into Git. Then, if we want to do automated regression testing, we should maybe not do this on production, we should set up automatically our own environments for that, install our code, load test data, which is as well a pretty heavy problem for some people, and then run our loads, check the results, and validate them against expectations. So, in fact, people came up, as we are working in the BI world a lot with database stuff. Yes, we need to have the database objects and the loads branched, merged, and versioned. We need to validate this kind of objects after we have merged the objects together. We need to install them on the database, then we need to run the loads, and then we need to get the results. And more you see that this thing is not like a 5-minute thing to set up, but it becomes very, very complicated. So at the end, when we do automatic deployment, we need to calculate automatically the differences, write deployment scripts, validate the deployment scripts, and deploy, and we're happy, we're done. No, we're not, because if something goes wrong, we need to write rollback scripts and roll back. So it needs to go in both directions. And if you ever try to do this manually, about 20 years ago we worked with a tool called like Flyway, where you need to write forwards and backwards scripts manually. It was fascinating, the tool worked, but it was so much manual work, so you don't win a prize if you try to do this manually. You need to find a way of automate all of this. And now I present you the solutions that we have found for this kind of problems, but it might be that you have found better solutions. Please tell me afterwards. I'm always open to discuss that. So what did we try? We tried to make it simpler. And our solution to this complicated process was to say, what is the target, what we want to achieve? What do we want to deploy? We don't want to deploy database objects. We don't want to deploy loads. We want to deploy a model with meaning that will define which kind of data shall be loaded, which kind of history shall be created about this data, and what is the target of it. And if we apply this and say, okay, we have a data model that by automation, by patterns, we can translate into code, we can start the CICD process on the model level. So instead of database objects and load, it's only the model that we need to branch, merge, and version. We need to validate a model, we need to install a model, and makes it already a little bit simpler. The next thing is to figure out how to work with this model We just went to the Java people and said, okay, is there a process to do that in a very good way? And they said, yes, there is Git flow. Read about it and implement it the same way. And what did we figure out? It's Git flow works with the assumption that you take something that you have, you create a branch, you do the changes on this branch, and when you're finished, you merged your changed version with the development, test, or production branch. So you need to find a way how to do that. And how does Git work? Git was created for files. It was never created for SQL. It was never created for any binary files. And it was created on a line-by-line comparison. So we said, okay, let's assuming that is what Git is doing. So how do we create a model that is compatible with that? And our solution was that we take every single object that is doing something in our data model and create a corresponding file. That's the first step. The second thing is, when we did that, we got a lot of wrong positives because we did write these files that they are human readable in JSON format. And JSON is not sorted and it has always a little bit of different structure. So we applied on top of it that we prettified the files, that we sorted the files. And now with applying these few basic principles, we got now model descriptions that can be merged. If we like add a new entity, it adds a new file, means that when I merge the stuff in Git, I will see exactly what appeared. If I delete something, a file disappears and you have it in the list. And now the whole Git merge process starts to make sense. And after that, it's very simple. You just follow the literature on these topics. Next thing is, if you have the model description of your desired state, you still need to calculate the differences. And for that, we have written an engine which is taking, in fact, the code that is installed in your database and the flows that are installed, not theoretically installed, but really reading the physical implementation, creating a model out of it, and then you can compare it against the desired state that you want to achieve. And if you have this both information, then it's pretty simple. Then you can compare them and define, okay, this entity needs to be created, this entity needs to be changed, some columns need to be added, and you can write all the diff scripts. But you need to automate it. You could do this manually, but this is really, really tiring work, and that you make some mistakes is the chance is very, very high. So this was at the end our solution. A Git flow compatible model, automated regression testing. We have created some APIs to set up new environments, to load the model into the environment, to run some data loads, to get the results all through REST APIs. And by that we became universal, that we now can use whatever testing tool you have. If you have Tosca Quality Center, we used Postman in the back in the past, we use now JMeter because it's more flexible. It doesn't depend anymore. It becomes really universal that if you have REST APIs for this kind of steps, that you can use whatever you like. And we have created a module which can take two models, compare them and generate the differences, either executing them directly against the target or writing a bash script with curl calls to execute them on the target environment. So this is solution one. Instead of storing the code, merging code, we are on a logical level. The second thing is, we have created a tool covering the full development process. Because we were not able to cope with model and code from many different parts, we have put in everything in a model, in one tool, which is model driven. So you start with the model and you connect data to it, and it generates all this kind of information. And based on the BARC research, we have created the tool with the best time to market, and this is exactly because it's driven by this approach that we start with a model, link it, and we can deploy it immediately in a completely automated way. So imagine that you want to add in your business model a new entity. If you're in banking, maybe account, and in the same second you add it to the model. This same engine that we use for CICD will deploy directly onto your database. and you can test it right away, which is very, very cool. But now you should get afraid and say, but wait, how do I control it? Because now everything which I work with gets deployed directly to my database, to my flows and everything. The point is, the solution for that is the third part where Snowflake comes into the game, that we need sandboxes. So we work on sandboxes, and then we need the deployment process to deploy everything. And this allows us then become very agile, because we had like clients like Deutsche Bahn in Germany. They said we want to integrate 2 or 3 different data sources. They started with that, but in an agile fashion, in every sprint, they added few entities, and they were able to create a really, really big model with a lot of data sources and a lot of output products. So in fact, this is the full process you need to automate. Disregarding if you do it with our tool or with your combination of tools, you need to set up the infrastructure. You need to convert your model into code. In the best case, it's two-way. So we are doing that. As we have no metadata repository in between, we read as well the code directly out of the database. We needed to do that anyway for this comparison of environments. Then testing needs to be automated. Deployment needs to be automated. And as well, operations should reconfigure itself, because that's a part that I've seen that many people forget. If you really deploy in an agile way, your production system somehow needs to recognize the new parts that were deployed, pick them up into the master jobs and run them automatically, so that you don't need to reconfigure anything. Good. If somebody's interested more in the tool itself, I'm here. I would skip that a little bit, but that's general the approach. We need to stage data, we need to historize it and output it, but I think we can talk about that later. So the last thing is the sandboxing part, because it is possible with a Git flow based approach, the 2 developers branch off the development branch at the same time, or even developer A branches earlier, developer B branches later. But now the stuff that developer B does is earlier signed off by the business user, and he needs to bring it back earlier. And to separate the 2 different development lines, we need to be able to work in separate environments. In Git, you have the working folder, which is the main attachment point where you do your changes. So what is the equivalent if you work with in the data world to a working folder in the Java world? And for us, it's the definition, it's one environment of the database and the tool, IDE, whatever, talking to the database, changing the model or changing the code. And in our case, we have removed the repository from the equation. So this means that if you are working in the Datavault Builder, we're storing all the metadata in the database, and we're storing the structures in the database, and we are storing as well the data in the database. So everything is located in the database. So the database as such is our working folder. And Snowflake has a great functionality that you can zero copy clone a database. What is that? If you are coming from the Oracle world, you maybe know the concept of pluggable databases. It was that you could just copy a database, plug it in, but the problem is with Oracle installation, you need to have the resources to run everything. In Snowflake, it's a virtual copy, so it doesn't copy really the full data set, but it copies the pointers to the data. And the cool thing about this cloning process is it's very, very fast. And you don't pay for the copy, because you haven't copied the data, but you have copied only the pointers to the data. Now, as we have stored the structures and the metadata in the database, this was cloned as well with the database. So we can set up a new instance of our Datavault Builder. We use Docker deployments for that we can really spin up new environments very, very fast. It connects again to the new cloned database, and you have a perfect copy of your integrated dev. So every developer, if he starts a new story, he clones a database, and this is not done by himself, but usually use some kind of pipeline tools. We use internally Jenkins. Some of our clients are using Azure DevOps. But you do whatever you like, but the zero copy cloning thing is just one SQL command. In fact, these are 2, but marketing line it's 1 line. And then you do your changes. Now, if you did your changes in the sandbox, you can't use the zero copy clone mechanism anymore to bring your changes back into your integrated dev, but that's not a problem. There before we have defined this Git flow based process where you can export the model of your sandbox. It gives you all the JSON files and you can merge it together with the integrated dev box and deploy it to the integrated dev box. And the cool thing is, if you work now with this distributed development approach where every developer has its own sandbox and every developer is using a branch in Git for his changes, you can figure out in the integrated dev the developer B did some kind of errors and you can't deploy this further to test, but developer A delivered a little bit later, but he's already ready, and you can again switch the priorities. And this is what we had in the beginning. So not only changing business priorities, but changing durations in development or problems with testing can change the order of deployments again and again. So this is what you should cover in your process. Think through if you can manage that, and only if you have this kind of requirements covered, you can start automating this whole pipeline. So a very, very short summary. Our solution to create a working CICD implementation is use a model-driven approach. Don't work on the code level. The code level can change. Even the requirements didn't change. Use the Git flow-based approach. So you need to have the model description in a format which is compatible with Git. And really, if you're looking for tools, challenge that. Because I have seen so many, even from big providers, solutions that claim they are Git compatible, and if you look what they are doing in the background, it's terrible. There was one tool from Oracle that did like 150 commits if you did just a simple saving of your data model without any changes and stuff like that, or they're deploying just the changes instead of the state. So really pay attention to it. Ask the people what they're really committing to the Git repository. Then for us, but that might be different for you, we have found that one tool makes it much, much simpler if it's covering everything. Still, if you have several tools, you can use the same Git repository to link the deployments of the different tools together. Then you just need to set up the sandbox for all the tools that you have and see that they deploy to the same branch. And the last bit, which makes it very, very simple to reach this state, is the sandboxing approach on Snowflake. You will manage to do this as well with other databases. We have clients using different databases, but here it's really built in. So if you're using Snowflake, use that. If you're using other database, you will need to find another way, and it means that you maybe don't clone all the data from your dev box because you will not have enough space on your physical machine, but maybe that you clone only the structures and that you use some kind of subsetting tools to populate your test sets using Jailer or Informatica, MDM, whatever, but it will involve much more effort to create that. So that would be my very, very short introduction on the main issues I see when creating a CI/CD pipeline, how we solved it, and which kind of considerations we did. Are there any questions? Is anybody of you already using a CI/CD pipeline that's working for him? At least someone. Good. Is somebody planning to do some CI/CD pipelines? Yeah, okay. Good. So, in that case, I thank you very much. And if there are any questions, as I say, please contact me on LinkedIn. I'm happy to discuss this kind of topics as well, not only regarding our tool, but as well in general, because I'm very interested in data modeling as well. If you have any other data modeling questions. So,
my question is, so this one, the CICD which we saw is about, all about Snowflake, but what about having a solution where multiple areas like multiple DBs and maybe cloud as well as on-prem, so we have like a hybrid kind of model.
Good.
And then
Okay, good.
how to achieve CI/CD
Good. So one last question was, if you don't have just one database, but you have different databases involved, if you have a hybrid approach, how you can achieve that? And my only solution to that is divide and conquer. Find a solution for every part. And if the deployments are really linked, that they need to be deployed at the same time, then use the same Git branches and link it in the Git repository together. That's the only approach I know. And yeah.
Does this approach work particularly well with Snowflake because every object can be expressed in SQL and not every other database can?
So the question is if it works explicitly well in Snowflake because everything can be expressed in SQL. In fact, we are supporting the same process for Oracle, all SQL Server variants, Exasol, Azure Synapse Analytics. It works in all the databases. The part which is very, very cool in Snowflake is the creation of the sandboxes. Because this is the only database vendor that I know that doesn't let you pay for the sandboxes extra. And that it's very, very fast and very, very simple to achieve. Because, yeah, even if you don't have a CICD pipeline in place, you can do a sandbox just manually by typing in the SQL commands. Good luck with Oracle. Sorry. Good. So thank you very much.